All right, we're going to continue with section 3.4. This time we're going to talk about logarithmic equations. So last video we talked about exponentials where our exponents were the variables. Here we can clearly see we've got logarithms. And so we've got a couple different problems. We've got like, hey, just like a regular log equals a number. Or what do I do there? I've got a specific problem with a natural log equal a number. I've got a problem where you have logs on both sides. So these all are different types of scenarios and ways to kind of break these down and solve them. That's why it makes this section definitely more difficult. So that's why and this is, again, take down this, write this down. I'd highly suggest you rewatch this video, ask me any questions that you have, because it is hard to remember all these different steps. Okay, so I've got a log equal to a number. So whenever you have a log equal to a number, the first thing I would say is put in exponential form. So that's the first thing I'm going to do here. I'm going to put this guy in exponential form. I'm just kind of writing what I'm doing, and I would suggest for your notes, you'd say, hey, this is exponential form, just so you kind of remember that. So remember, this 2, that's a base of 2, so it's going to be 2 to the 4th power and then equals that. So I'll have 2 to the 4th power equals, and then that x plus 4. So I don't need those parentheses anymore. Okay, well, 2 to the 4th power, that's 16. And then that equals x plus 4. And then I just have to go ahead and solve it. So I'll minus 4 here, minus 4 here, and I'll get 12 equals x, or x equals 12. Now with logarithm or with exponentials, anytime we got an answer, positive or negative, didn't matter. With logarithms, you got to be careful because the domain of a logarithm is going to be anything bigger than 0. So you can't take the log of a negative number. So I just need to confirm, if I plug in 12, I'll take the log of 16. So it'll be log base 2 of 16. That's okay because that's a positive number. So that does work out. And you can check this. If you typed in on Desmos log base 2 parentheses 12 plus 4 equals, you get 4. So you can check that one. Okay, next one. Very similar, except it's a natural log. Well, the one thing I need to do here is I like to rewrite this and say, well, let's remember what a specific problem this is. Natural log is log base e. Now, after I establish that, put in exponential form. E to the 4th equals, and then x minus 3. So I get e to the 4th equals x minus 3. And just a reminder what I'm kind of doing here, I'm putting that in exponential form. So I always like to write it for your guys' notes, just so if you do refer back to it, you can see what we're doing. Now notice I don't have x by itself either. I got to add 3 to both sides, add 3. So that's e to the 4th plus 3 equals x. That's your exact form answer. Now, if it says decimal, you're going to have to go to Desmos and type in e to the 4th and then plus 3. And then get your answer that way. So depending on what it wants, if this is a short answer and you leave it like that, that's 100% fine. Okay, next situation, you've got a log equal log. Now, very similarly to when we had, base of 3 to this equals, and then base of 3 to this type of problem. Just like when we had that, we were able to set the exponents equal to each other. In the same regard, if I have a log base 3 equals a log base 3, I'm able to kind of break those down. So I'm able to get rid of all of those, the log bases, and just set the parentheses equal to each other, which is kind of nice. But again, that's only, notice these guys, it was a log equal a number. That's a different scenario. But if I have a log equal the same log base, it has to be log base 3 equals log base 3, or log base 5 equals log base 5, which I do have. In that case, I can just set a 5x minus 1 equal to x plus 7. And then go ahead and draw your line down and go ahead and solve it. So in this case, I'm going to minus x to both sides. That'll give me 4x. I can also get rid of this 1 by adding 1 to both sides. And so in this case, that'll cancel that out there. These would cancel. So I get 4x equal to 8. And then, of course, you're just going to divide both sides by 4. And so I get x equal 2. Now, that's okay, because if I type in 5 times 2, which is 10, and then 10 minus 1 is 9, I'm taking the log of a positive number. Same thing over here. I'm taking 2 plus that's 7. So I'm taking the log of a positive number. So that's completely fine. It's just if it's a log of a negative, that's not okay. Okay. This has log minus a log equal a log. Well, the first thing I'm going to have to do here is I'm going to have to make sure that I have a situation where I got to break this down first. Well, we spent some time this week already breaking these down. I've got a log with the same base, but they're subtracted. So I know that I can simplify that and write that as the log base 6 of 1, except I've got division going on. And this is where I was kind of talking about this. This is why I said it was so kind of important that you take, hey, the top, that's going to go up here, that first one. And then the second one, that 5, that's going to go in the denominator. And then I didn't do anything on that right-hand side. So notice that I condensed that down. So it's from 2 logarithms to 1 logarithm. That's really important. That's why I said that knowing that's going to be very, very, very helpful. Now, knowing that based upon what we did in this last example where log base 3 equals log base 3, I've got log base 6 equals to log base 6. So basically all I have to do here is I just have to set what's in these parentheses. So 3x plus 14 over 5. I'm going to set that equal to what's in this parentheses, which is 2x. And then I have to go ahead and solve it. Now, some of you might get a little, what do I do here? Well, the first thing I would do is get rid of this whole thing. This is dividing by 5. The whole thing is being divided by 5. The opposite of dividing by 5 is to times. So I can times this by 5. I can times that by 5. That'll give me 3x plus 14 equals 10x. And then go ahead and solve it. So I can minus 3x to both sides. That'll give you 14 equals 7x. Divide both sides by 7, and I get 2 equals x, or x equals 2. Now, they're not always going to come out nice and clean. You can get a lot of fractions. You can get 3/2, 5/4. If you leave them in decimal form, that's fine. If you leave them in fractional form, that's fine too, depending if you can, reduce it. But 14 divided by 2 is, or 14 divided by 7 is 2. So that's my final answer for that one. So notice the difference between these two type of problems. I've got this first one where it was just a log equal log. That's much quicker because I set these equal to each other. This one, the first thing was I had to condense it down this left side. So it went from 2 logs to 1 log. And then I was able to do that. So you kind of have to see the difference. So that's why already you can see how many different types of situations we've been dealing with. A log equaling a number, a natural log equaling a number, a log equaling a log. This one where it's almost the same, but I have to condense that one down. Okay, this one is a situation where if I kind of go through here, you can kind of see that I've got this log plus a log equal a number. So I'm going to do what I did last time, which is I'm going to condense this side down. So it's just that. So notice that I can condense this. This is saying with multiplication, I've got to times 5x by the x minus 1. So I have to multiply those. And yes, you're going to kind of see that we're going to have to distribute this 5x here and this 5x there. So that would give me log 5x times x, that's 5x squared. 5x times a negative 1, that's a negative 5x. And that equals 2. This one's going to go back to the first type of problem. Now that I've done that, I have a log equal a number. So we put that one in exponential form. So I'm going to do the same thing. Now, there's no base. We call this a common logarithm. What's the base of a common logarithm? That's a 10. So I need to take that 10 to the second equal that. So I would have here, this would be 10 to the second power equals 5x squared minus 5x. And we also know that that's going to give you simply just 100, because 10 times 10. But notice I have a quadratic. So this isn't just a linear equation where you're trying to get x's on one side and numbers on the other side. This is a quadratic. I got to get everything on one side. Now, like I said in the last video, when you have this, you want your leading coefficient positive. So that is positive. It's easier just to subtract this 100 over. There's no like term, so that's just going to leave me 0 equals 5x squared minus 5x minus 100. Now I need to factor this. One thing I would tell you that you can kind of see here is that luckily for us, this is something that I can actually do a little bit more with. And what do I mean by that? I can actually GCF out of 5. That's a lot easier to do than try to factoring it the other way. Some of you guys struggle when your leading coefficient's not 1. So if I GCF out of 5, so 5x squared divided by 5 is just a 1x squared, or x squared. Negative 5 divided by 5, that's a negative 1, or just negative. You can do it this way. And then negative 100 divided by 5 is negative 20. Well, now I can go ahead and factor that one a lot quicker, because this is looking for two numbers that multiply to a negative 20, but add to a negative 1. Like I said, we've been doing this since day 1, so we should be really good at factoring at this point. So that would give me, in this case, x minus 5 and x plus 4. Because negative 5 times 4 gives you negative 20, but negative 5 plus 4 gives you negative 1. And then the last step, solve these. This would give you x equal 5. And then this one would give you x equals negative 4. And so like we said, we need to kind of check those. If I plug 5 back into here, I'm okay. But if I plug -4, that's not okay, because 5 times -4 is -20. You can't take the log of a negative number, which means I'm getting 2 answers, but this one's extraneous. Now with exponential equations, you don't have to worry about that. With logarithms, you do. All these other answers, and it's not that my answer was negative, it's just that if I plug it back into my original equation, as long as I'm not taking the log of a negative number, I'm okay. But here I did. Now, one other thing to mention too is you can use Desmos to kind of help you out a little bit. So like, let's say I wanted to say, can I check this answer, or use Desmos to check or actually do it for me? So what I'm going to do is this. Here's what you can do. Now, this doesn't really work all that well, but if I do the following, take my equation, there's a left side equals the right side. Now, it won't graph just a number, but if I type in y equals, it will. And what you're doing is you're looking for where it crosses. Now, in this case, what we're looking for, it was equal to 2. Okay, good, to make sure. What we're looking for there is where are they crossing, but we're only worried about the x value there, because when we have x equal 5, both the left-hand side of this equation, the left-hand side would equal 2 and the right-hand side would equal 2. So you can use Desmos to check your answer if you say, okay, type in the left side of the equation and then type in the right side of the equation. Just make sure that if the right side or left side is just a number, you have to type in into y is y equal. Otherwise, you can see here, it's not going to graph it. So type it in like that, then find out where they cross. And it could cross twice. Notice that this one does not cross twice because we only have one real solution here. The other one we call extraneous. Okay, last problem. Here's a good application where we use this. So we're going back to money. And we talked about how to, you're investing money and where you get it. This one says you're investing 500. It says an annual interest rate of 6.75%, compounded continuously. So that tells you which equation you're going to use. How long will it take to double? Now, whenever you're dealing with these questions and the question says, how long will it take? That's telling you you're going to have to solve. And when you have to solve exponential equations, you're going to have to go ahead and do what we've been doing. So here, let's go back with what we know. First off, compounded continuously tells me I'm using that PERT equation. So A is what I'm ending up at, P is what I'm starting with, E is just the number E, R is this percentage, but the decimal moved, and T is how much time. So let's plug in what we know. We know where we're starting with 500. E is going to stay E. R, you have to move this decimal twice. So this is going to be 0.0675 times T. We don't know what T is. Okay, well, what's A? Well, we need to say how long is it going to take to double. So if I have 500 and I double it, well, that of course is going to be 1,000. Some other question might say, how long will it take to invest 500 to end up with 700? In which case your final amount here would be 700. Now we're going to go ahead and solve it. So first I got to get E by itself. So I'm going to have to divide this by 500. Divide this by 500. I'll get 2 equals E 0.0675 T. Now, we learned in the last video, if I have an E problem, I'm going to take the natural log of both sides. So I take the natural log of both of these sides. The natural log and E are going to cancel out, which is why I use them. Here, I have natural log of 2, and this just leaves me with 0.0675 T. The last thing I need to do here is get T by itself. Well, the T is being attached and being times by this, so I'm going to divide both sides by this. Zero there. So I'm going to do that. So I have the natural log here. So I have the natural log of 2. So natural log of 2. And then I'm going to divide that by 0.0675. And that's 10 point, we'll say 27. So that would give you T equals 10.27. In this case, that's years. So it's going to take you, if you're only doubling 500, or sorry, you're only starting with 500 and it's compounded continuous at that rate, it's going to take you a little over 10 years to be able to do that.